Okay, so this is my quadrant, and so I'm putting alpha here, alpha degrees. Now I know here is my opposite now. Let me put it this way. This is my opposite, adjacent, and my hypotenuse. So the simple laws we learned earlier, which is the SOHCAHTOA. What does the SOHCAHTOA mean? If I want to get this angle, if I want to get the value of this angle, depending upon the position I'm standing and whatever I've been given. So if I want to get it, the opposite and hypotenuse in the ratio, we have what is called the SOA, the CA, and the TOA. Now what is the SOA means? Sine theta or sine alpha. I'm using alpha degrees. The sine alpha over here is equals to opposite. So this is my opposite and hypotenuse. So sine alpha is equals to my opposite on hypotenuse. Good. Then the next one, which is cos alpha. Let me bring it down. Cos. That is cos alpha, which is adjacent and the hypotenuse. So this one is also adjacent on hypotenuse. Then last, not the least, is TOA, tan theta. This is TOA, tan alpha, which is opposite. The word O, that means opposite and adjacent. So opposite on adjacent. Good. Now, why is there a need for you to know this in the course of the work? We are going to use this one to be able to deduce the size of the right angle triangle and deduce the law which will be used on the function. So if I've got my Cartesian plane, this is the Cartesian plane. Good. The Cartesian plane has both the x, or let me say the xy axis. The s on the horizontal axis and the y on the vertical axis. This is my point of origin. So I'll move. Then at any point, the angle created will be a quadrant. This is my angle theta here. I'm putting theta. And this is vertical. From coordinate geometry, we know that a vertical line will meet a horizontal line at right angle. So as I'm standing erect. So anything vertical, if I leave this marker and it goes down straight and it will meet the ground at an angle of 90 degrees. So here is 90 degrees. So this is my resultant force. So we call here R, or my hypotenuse. So from this, we can clearly see that this part from the initial deduction, I said the adjacent meets the acute angle at the point where the hypotenuse also meets the acute angle. So it tells me that this is my adjacent. And this place will be my opposite, because this part is facing the acute angle. So from here, if you really want to follow the law, the part here we have gotten y, and the part here we have gotten x, because everything here is x-axis, everything here is y-axis. So from the SOHCAHTOA we have known, making R the subject of our relation, what are we going to get? For instance, if I want to know, I want to find my x. What is x in relation to the hypotenuse? X and the hypotenuse. X is adjacent and the hypotenuse is also R. So what ratio will go with what? Adjacent hypotenuse. We know it's K. So we say cos theta. So cos theta is equals to my adjacent and then hypotenuse. So I'm going to get x on magnitude R. So to make x the subject, we say we multiply through by magnitude R, here by magnitude R, and here by magnitude R. So when we cancel magnitude R at this point, we have our x to be equals to magnitude R cos theta. This is equation 1. We are basing on this to deduce the law. Okay, then let's look at the second section also. How do we get y? Y is facing the acute angle and the hypotenuse. So which law will go with opposite hypotenuse? A SOA. So we say sine theta is equals to opposite, which is y here, on magnitude r. Okay, so to make y the subject means that the r will come and multiply sine theta. So we get y to be equals to magnitude r sine theta. This is equation 2. Good. So from this, I will draw the diagram again once I maintain this to deduce from the law of trigonometry to be able to transpose the general trigonometry function formula.